So this is the equation we use to sum up the terms of an arithmetic sequence. So how can we derive this formula here? So Sn equals, now the first term is a. The second term on an arithmetic sequence is a plus d, where d is the common difference. A is the first term, d is the common difference. Now that's the second term, plus a plus 2d, that's the third term. Now I'm going to write the last three terms. Now if I label the last term as L, then it means the second last term will be L minus D, and the third last will be L minus 2D. So this will be L minus 2D, L minus D, L. So that's going to be our first equation. What this just means is we are summing up every single term. We're just adding up all the terms of a general arithmetic sequence. Not a specific one, but it's general. Now, we are going to write this backwards because we know that 1 plus 3 plus 5 is the same as 5 plus 3 plus 1. Both give the same answer. So therefore, I can just rewrite this the other way around. So starting with the L. Oh, sorry, it's minus here. Okay, plus, plus, and then A plus 2D, A plus D, A. Now, this is our second equation. Now, we're just going to add these two equations. So, on the left-hand side, we add Sn with Sn, we get 2Sn. And then on the right-hand side, when we add these terms, notice how we have A plus L. A plus L. But the D is going to be a positive D here and a negative D here. So the D's will basically subtract and give us 0. I have A plus L here, 2D minus 2D. Again, A plus L here, negative 2D plus 2D. Negative D plus D. So I am going to be left with A plus L's, right? But how many A plus L's do I have? So I know that I'll have A plus L's, but how many of them? Now, what I need to remember is when I made this general series here, I basically did not pick a specific number of terms that I'm trying to sum up. So I basically went for n terms. So I have n terms. If I have n terms, therefore I have n number of A plus L's. So if I had 7 terms, then I would have 7 A plus L's. Okay, but since I have n terms, therefore it's n number of A plus L's. Now I'm going to divide both sides by the 2. So Sn is equals to n over 2 A plus L. Now, if I have n number of terms, and remember, the last term will be the n term because I have n number of terms. So if I had 7 terms, therefore the last term will be the 7th term. So I have n number of terms. The last term will be the n term. So that's why I can write down the last term as Tn equals A plus n minus 1 D. So I'll replace L with A plus n minus 1 D. So now I can just remove this bracket. Sorry, I can remove this bracket here. No, I didn't close my brackets properly. Yeah, now we're good. So I just need to remove this bracket here. So when I remove that bracket, I can just add a and a, giving me 2a. So that's how we can derive this formula. Now we'll proceed to derive the equation that we use for geometric sequences. 1 minus r to the n over 1 minus r. So this is sum to n terms for a geometric series. So how can we write down a general geometric series? So again, Sn equals. So the first term will be a plus. The second term will be a r. The third term will be a r squared. Plus dot 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 dot. And then remember the nth term. The nth term for a geometric is a r to the n minus 1. Okay, because I have an n number of terms, therefore the last term will be a r to the n minus 1. Now we'll call this equation 1. Now to form equation 2, what I will do here is I won't just write them backwards like I did with arithmetic, but instead I'm just going to multiply both sides by r. By the way, r is the common ratio. So in case it's not clear, so r is the common ratio. Multiply both sides by r. So Sn times r becomes rsn. So if I multiply a plus by r, it becomes ar. Now I have to multiply all these terms by r. You don't just multiply one term or the first and the last, you multiply all of them. Then the second term becomes ar squared. Then the third term becomes ar cubed, and so on and so on. Now I am going to write the second last term, which if the last term here is ar to the n minus 1, then means the second last must have been ar to the n minus 2. So if I take ar to the n minus 2 and I times it by r, therefore I'll have ar, sorry, I meant ar to the n minus 2. Yeah, so if I take ar to the n minus 2, which is the second last term, and I multiply it by r, therefore I'm going to have ar to the n minus 1. Because these bases are the same, so I add exponents. When I add exponents, I'll have the negative 2 plus 1, which will give me negative 1. So I have ar to the n minus 1 plus, now this very last term, if I multiply it with r, I'll just have ar to the n. And that's our second equation. Now, I am going to subtract these two terms, these two equations. So equation 1 minus equation 2. So Sn minus Rsn, that's what I'll have on the left hand side. Now, on the right hand side, what will I have? Let's see. I'll have a minus, it doesn't have a like term there. Okay, so I'll just have the a there. But see, I have a ar here and I have a ar there. I have ar squared here and ar squared here. I have a ar to the n minus 1 here r to the n minus 1. So, in other words, this term, right, won't have a matching term on the sequence, on the series, I mean. And this term here does not have a matching term on this top one. So those will be the only two remaining terms. Everything else will cancel out as I'm subtracting. Even everything in between here will cancel out. So therefore, I'll just have a left at the top minus what is left at the bottom. So now what I can do is I'll take a common factor of Sn here, 1 minus r equals, here I'll take a common factor of a, and then I can divide both sides by 1 minus r.